And last for the week, we have another short video about correlation. So this video covers chapter 11, more about correlation. Chapter 10, 11, and 12, much shorter little chapters, just extra information about these different types of studies. So we're talking here about association studies, where you're correlating or associating two different variables. So correlation is kind of very similar to association. What's the relationship between the two? In order to find the relationship, you use a statistic called correlation. You may use a statistic for continuous data, that would be a Pearson R, or you can use a statistic that would be for categorical data, not the same thing. But there are still measures of relationships. We still call them correlation, whether or not we're looking at continuous data or categorical data. So today, we're just going to do a quick little look at more about correlational studies. So correlation is not causation. I'm telling you, you see this everywhere, this cute little meme. It's hilarious. Correlation is not causation. Basically, just because there's a relationship between two things, just because if one goes up, the other goes down, or if one goes up, the other one goes up, doesn't mean that that one going up is causing the other one to go up. It's just an association. There might be some other third variable that's causing those. There's a great example of that in your textbook when you're looking at the parents, the TV, the studying. So that's a great example of a third variable creating the cause that makes those two things connected. Or it might be that one does cause the other, but you don't know which one causes which one, because correlation is not a way to figure out the direction. So if you're just doing a correlation, all you can see is that they're related. You can't tell which one caused the other, which one came first, or which one is a result. You can't tell that. All you can tell is, yes, there's a relationship. And so very, very important, correlation is not causation. This is something to remember for the rest of your life. It will help you. Even if you never, ever want to see research design or statistics, it is critical that you remember correlation is not causation. Okay, a scatter plot. You may have remembered these from, math or something in your past. A scatter plot is simply a way of looking at data. It's a bunch of dots on a page where you're graphing on two different axes, one variable. So what's the value with one? What's the value with the other? Then you make that graph. So you get a sense of the relationship with a quick glance. You can practice with this if you want. I just want you to alert you that scatter plots are used often to demonstrate relationships between data. You can look at your book, page 274, 278, for examples. Here's an example of a scatter plot. And so you've got whatever the axis is on the left, or on the vertical axis, and then the horizontal axis. And you're looking at what is the score for both of these things, and does there seem to be a relationship? So if as one goes up, does the other one go up? And in this case, yes, it does look like there is a positive relationship. Sorry, as one goes up, the other one goes up. And so you would say there is a positive correlation here. This scatter plot shows a relationship. So correlation can be positive or negative. We kind of went over this earlier this week. I'm just going to lay it out for you one more time. A positive correlation is when two variables change in the same direction. So if they change, one of them might go up, the other one will go up. If one goes down, the other one goes down. They change in the same direction. They can be up or down to be a positive correlation. A negative correlation is when they go in opposite directions. One goes up and the other goes down. If there's no relationship, then your scatter plot is going to look just like a bunch of dots with no relationship. You're not going to be able to see any sort of way to draw a line through that relationship that portrays the relationship very well at all. So for example, when you look at this scatter plot, you can kind of fit a line through it. when you look at a scatter plot of a zero correlation, you won't be able to fit a line. It's just going to be a bunch of dots that don't go in any particular direction. And that means there's no relationship. It's a zero, basically a zero correlation. You can use correlation to predict or describe. So if you want to build a study that's an association study, and most studies are association studies, very few studies can really prove causality. This is because it's really difficult to control all of the variables. And if you do control all the variables, sometimes you have to do it in a lab and it's not very externally valid. But a lot of times with humans, you can't control everything because humans are very complex. So almost any study that you read is going to be really about association and not causality. So you can use association. It's so useful. You can use it to predict. You can use it to describe. If you know one thing, you can say, well, this is highly associated with the other. So it's probable that if you're high on this, you'll be, high on the other one. Or if it's probable that if you're really low on this, then you'll be high on the other. You're using the association to predict one value from the other value, or predict, kind of like a basic where it is. And so when I look at depression, say a client comes in and they say, I feel blue. Well, those words, I feel blue, are actually highly correlated with depression. And so just on the basis of them saying, I feel blue, I'm going to think, well, it's very likely that they're depressed, because I feel blue and depression are positively correlated. So I can predict that they are depressed based on them saying, I feel blue. Now, of course, I'm going to go really do a much more thorough diagnostic interview to figure out if they really are depressed or not. I'm not going to just use that one sentence, I feel blue, to diagnose them. That's not very thorough or precise. But I can predict, oh, this is something I need to check out. They said, I feel blue. They're probably depressed. Let me check it out. So that's an example of how you might use a prediction in real life. You can also describe the type of relationship. And so I would say the type of relationship between feeling blue and being depressed is a positive relationship. And then I know more about that relationship. So I need to know that before I predict anything. So unless you know the nature of the relationship, the description, then you can't make any predictions. You have to know the nature of the relationship first, then you can make predictions. And so you can use association studies or correlations to describe the nature of a relationship. And then what you can do is you can therefore predict based on that nature of a relationship. You cannot attribute causality. You can't say X causes Y. All you can say is that X is associated with Y, or X has a positive relationship to Y. So we talked about the Pearson R. That's the statistic that you use in general. There are other ones. We'll worry about them later next week. So the yeah. Can you say that word 10 times for me? Yeah. The statistic you use for correlation in general, when you're looking at two continuous variables, is the Pearson correlation, the Pearson R, sometimes the Pearson product moments. There are lots of things that they use to call this Pearson statistic. But we usually just call it the Pearson R or an R value. So what happens is you use this statistic. So the statistic is a mathematical equation. You put your data in the equation and it comes out with the result, which we call an R value. And so that R value will range between negative 1.0 and positive 1.0. It's somewhere between those two. And depending on where it is, you can say whether or not it's a strong correlation or a weak correlation. So when you interpret correlation, you're always looking at the absolute value. So anything that's closer to zero is a very weak or a zero correlation. So anything that's below either positive 0.1 or negative 0.1 would be so weak that I would call it no correlation. They're not correlated. But as it approaches either positive 1 or negative 1, then that correlation becomes stronger and stronger and stronger. A correlation of 1.0 or negative 1.0 is called a perfect correlation. And they pretty much don't exist in real life. They might exist in a lab, but in real life, it is very rare to see a perfect correlation because variation happens. Things vary. So most correlations you see in psychological literature are mostly, 0.5 or below, 0.6 maybe. Sometimes 0.7 is pretty exciting, but you're like looking more at, in the 0.2s, 0.3s, 0.4s, and those are pretty interesting. When you're looking at retest reliability, you want something higher, because what you're asking is the same question from day 1 to day 3. So if I say, do you like the color blue? You would say yes on Wednesday. You should say yes on Friday. And so you're going to have a higher correlation in general for retest reliability. But for things like, what's the correlation between anxiety and childhood disciplinary practices, then there may be a relationship, but that relationship is not going to be very, very strong. It's unusual to find a very strong relationship. So, for example, correlations this is what they look like when you look at them on paper. R equals 0.53 or R equals 0.19. That's what your R value will probably look like. It's 2 decimals. If you've got R equals 0.03, zero correlation. You could say, well, R equals 0.03 to be exact, but it's pretty much no correlation. There's really no relationship. So see how fast this video was? So much better. It's a Friday, and you can, or maybe it's a Friday, maybe you're doing your work early. So you can feel like you can just work on other things. I know that introduction is on your mind. You want to get that in before Saturday night. So to summarize, correlation is a measure of how 2 variables are related to each other. If one variable changes when the other changes, then you have a relationship. If they both change in the same direction, it's positive. If they change in opposite directions, it's still a relationship. It's just a negative relationship. It's not a zero relationship. It's a negative relationship. Correlation is measured by Pearson R. That's one of the statistical tests that are used to measure correlation. There are others. That's the one that I'm just going to introduce you to today. So that's it for today. That's it for correlation. If you're doing an association study, that it makes sense to use correlation when you're measuring your results or when you're calculating your statistics, then you can use this chapter to help you build your study. So if you're doing an association study, what you want to say is, here is variable 1, here's variable 2, here's how I'm operationalizing variable 1, here's how I'm operationalizing variable 2, right? So the measure that you're using for each of those variables. And then you're going to take your results and you're going to correlate them. You're going to create some sort of statistic that represents how they're associated. That's correlation. Okay, have a great weekend. Enjoy those introductions. Again, I was so available to you to help. Please email if you need my help, and I will be happy to chat with you. Also, do not wait until the last second, because I'm human and I may not be able to help you at the last second. I might be asleep at Saturday night at 11:30 when you all of a sudden decide you want my help. So think ahead and set up an appointment with me. I'm happy to help. Have a great weekend, and we'll talk to you next week.